Okay, Assalamualaikum and very good morning to everyone. Okay, so today if we continue our topic, which is process synchronizations. Okay, in this topic, you will learn about how the computing process will affect or be affected by other process executing in the system. So computing process can be either directly share a logical address space, either the code or the data, or it can be allowed to share data only through the files or messages. So in the previous chapters, you will learn how to achieve the use of threads. Okay, you will learn about the threads and the multi-threadings, how it being the concept, and also how they is being being operate. So since they have a thread and the multi-threads which is running concurrently, so the concurrent access has a possibility on the concurrent access to shared data, which can result in data inconsistency. Okay, so therefore in this chapter, you will discuss about the various mechanisms in order to ensure the orderly executions of the cooperating process that share the logical address space so that the data consistency is maintained. Okay, so kita akan maintain, kita tengok kalau dalam proses kita akan ada proses yang that concurrent process, or we call a cooperating process. Okay, some threads and we have a multi-threads, okay, that running concurrently. So how they share the data, how they share the codes, okay, at the same time they can run at the same time the data that can be accessed both process and that access concurrently can be maintained the consistency rate. So this is the object, the outline of this topic. Okay, some of the solutions are in the hardware solution and some of them are in the software solutions. So we have to look the concept saja, yang topik subjek ni dia lebih kepada konsep. It's very important when you have a multi-processor. So kita akan tengok kalau kita single processor, they are able to do the threads and the multi-threading. So macam mana dia maintain dia punya data consistency dia, and then dalam masa yang sama kita akan tengok ada juga some of this concept is being used, okay, in the multi-processing. So this is the objectives, okay, where you will be able to describe the critical section problems and illustrate the race conditions, okay, and you can see that the different solutions for the hardware solutions or the software solutions in order to maintain the synchronizations of the data or the process synchronization. So they demonstrate how the mutex logs, semaphores, monitors, and the condition variables can be used in order to solve the critical section problems, okay, and evaluate the tools that solve the critical section problems either in the low, moderate, and high contention scenarios. Okay. So previously we already discussed about the process can execute concurrently or in parallel. Okay, so kita dah tahu dah processes able dalam operating system, the process is able to can execute concurrently and it can be worked in the parallel. So this means one process may only partially complete execution before another process is being scheduled. In fact, kalau ada proses, it can be interrupted before another process is being scheduled. Okay, in fact, okay, a process may be interrupted at any point in its instruction stream, and the processing core may be assigned to execute instruction of another process. Okay, additionally, okay, we already introduced to you to execute instruction of another process. Introduce a parallel executions in which two instruction streams, okay, execute simultaneously on the separate processing core. So dalam chapter ni kita akan explain macam mana concurrent ataupun parallel execution can contribute in issues that involve in the integrity of data shared by the several process. So guys, sini kita akan nampak ada beberapa isu yang perlu diberi perhatian, okay, of the programmer, especially the designers for the operating system when you run a process that running in the concurrently. So there are several issues that need to be considered. Okay. Alright. So in these issues, okay, kita akan discuss about dia punya, okay, kita akan discuss dia punya isu dia ialah, okay, kita akan tengok we have a different process, okay. For example, we have a process 0, okay, and process 1 creating the child process using the fork function ataupun kita panggil the fork system call. So namanya P0 dengan P1 ni dia ada dia punya child process, maksudnya dia ada sub process that running. So apa yang berlaku ialah, okay, apa yang berlaku ialah the race conditions akan berlaku, okay, on the kernel variables, okay, di mana dia akan represent the next available process identifier. Okay, kita tahu setiap proses ada proses identifier dia sendiri. So kalau kita ada fork child, maknanya dia ada sub process. So dia akan create another sub process of ID, sub process ID yang sama, tapi dia akan tahu this is belong to the fork child. Child dia 2615. Okay, so P1 dia ada dia punya ni. Okay, ataupun dia sharing the same fork child. So apa yang berlaku ialah apabila dia P0 dan P1 dia running secara concurrently dan dia akan mengakses benda yang sama, maka dia akan berlaku we call as a race condition. Okay. Alright. So in the race conditions, okay, the race condition is happens where the situation where the several process access and manipulate the same data concurrently, and the outcome of the execution depends on the particular order in which the access takes place. So dia akan ada berlaku race conditions, okay, berlaku perebutan, okay, berlumba-lumba. Dia nakkan accessing the data ataupun the resources. Contohnya dia nakkan input device ataupun dia nak output device. Okay, the same forks function yang tadi tu dia perlukan akses pada proses pada certain data. Apabila berlaku perebutan di sini, dia akan dapati data yang diterima oleh kedua-dua tu adalah data yang inconsistent, data yang tidak boleh dipakai lah. Kalau kita dalam technical dia panggil sebagai garbage data. So dia kata as a garbage data lah. Okay. So to guard against the race condition, kita kena ensure that only one process at a time can be manipulating the variables. Okay. Kita kena pastikan dalam operating system kena pastikan benda ni. Apabila berlaku race conditions, kita make sure that only process dalam satu masa yang akan do some manipulations, okay, can access the data, and then to make sure they guarantee the process must be synchronized in some way. Okay, right. So therefore, the situations such as the just as described tadi akan frequently operate as a different parts of the system manipulate resources. Ini selalu berlaku, bukan sahaja data, dia akan berlaku race condition dari segi resources. Okay, contohnya dua sistem nak access, dua proses nak access memori pada masa yang sama. So macam mana operating system may decide which process need to be accessed that particular memory dalam pada masa tersebut. So ini akan berlaku apabila dia berlaku cooperating ataupun berlaku dalam concurrently ataupun parallel. Kalau dia berlaku in the sequential, dia tak akan berlaku lah. Dia tak akan berlaku race condition. Okay, so furthermore dalam chapter ni kita akan tengok the growing the importance of multi-core system has brought an increased emphasis on developing multi-threaded application. So dalam ni kita akan tengok bukan sahaja single processor, kita akan tengok juga di dalam a multi-core. Multi-core maknanya you have more than one processes, okay, that running. Dan macam mana dia akan create, okay, macam mana dia boleh develop atau create the multi-threaded application. In such application, several threads which are quite possibly sharing data can be running in parallel on the different processing core. Okay, it's been clearly that we want to change the result from the such activity not to interfere with another process. Okay, kalau kita buat proses, kalau buat changes the result tu, kita nak pastikan kita nak kena pastikan aktiviti tu tak ada mengganggu atau mengganggu gugat proses yang lain. So that's why because of this important of this issue, we devote have a major portions to have a chapter on the process synchronization and coordination among cooperating process. That's why topik ni antara topik penting dalam principle of operating system, di mana how your process can be synchronized. Okay, how your process can be synchronized. Okay, when you have a multiple process running in a multiprocessor. Alright, so each process, okay, so we have a call dalam ni. Okay, kita akan tengok issue dulu and how we solve it. Okay, so the first thing, we begin the consideration of process synchronization by discussing the so-called critical section problems. Okay, dalam critical section problems ni, okay, we consider a system consisting of n process. Okay, kita assume saja, okay, dalam satu operating system kita ada n process. Kita tak tahu berapa banyak. Okay, dia bergantung kepada user. Okay, how many process, bergantung pada komputer, dan juga dia bergantung kepada user itu sendiri, berapa banyak program dia buka dalam masa yang sama. Then each process has a segment code, or we call as a critical section. Setiap proses ni, okay, kita consider dia ada n proses. So setiap proses dia ada critical section dia. Okay, critical section ni macam the segment of code lah. Okay, so in which proses ni may be changing. Okay, bila dia ada segment of code ni, dia akan menyebabkan ada perubahan pada variable dia. Kita update the table, writing the file and so on. Banyak. Setiap section, critical section ni dia ada aktiviti dia. Okay, antaranya ialah aktiviti dia ialah changes dia punya variable, you update dia punya table, okay, writing the file and then banyak lagi. Okay, kalau macam you access your system tu dengan database, so you akan write the file tu akan write into database, save dalam database, lepas tu ataupun you nak buka file daripada database. Okay, so the important features of the system is that when the one process is executing in the critical sections, there's no other process is allowed to execute in its critical section. So dalam case ini, apa yang kita buat ialah kita kena pastikan, okay, mana-mana proses yang tengah run dia punya critical section, so proses lain tidak dibenarkan, okay, dia tak benarkan execute dia punya critical section. Okay, there is no two processes, okay, are executing in their protocol that the processes can use to cooperate. So each process must request permission to enter its critical section. So untuk mengingatkan ini, apa kita buat? Setiap proses yang nakkan buat critical section, dia kena minta permission. Okay, permission in order to enter, masuk ke dalam entry critical section tadi. Okay, so bila dia minta critical sections, so how kita implement dia, kita akan letak satu section of code, implement this by request the entry section, macam function lah, kita letak satu entry function, lepas tu followed by critical section with the exit section and also the reminder section. So dia ada 3 benda. So dalam setiap proses yang masuk critical section tu, okay, dia ada 3 benda. So dia kena ada entry section, okay, lepas tu dia ada exit section, okay, and then dia ada reminder section. So critical section problem ni kita dah didesignkan as a protocol protokol, rules, okay, di mana processes yang corporate processes, okay, must follow this critical section problems. Okay, dia akan mesti, maknanya kalau setiap proses, satu proses dah masuk critical section, another proses tak boleh run or execute dia punya critical section. So, setiap proses nak buat critical section, kena ada permission. Okay, so bila dia ada permission, dia kena ada entry section, kena ada exit section, and also dia kena ada reminder section. So, the general structure of the typical process, okay, dia akan tunjuk lah. Okay, you boleh tengok dalam buku. Okay, so the entry section and the exit section are enclosed in the boxes to highlight the importance of the segment. So kat sini. So this is general structure of the process. So they must do. So this is the entry sections. Okay, and you have a critical section, and then you have exit section and the reminder section. So ini dia punya algorithm lah. Okay. Right. So apa yang apa yang diperlukan for solution to critical section problem ni ada 3 benda. Okay, pertama adalah dari segi mutual exclusion. Okay, mutual exclusion adalah di mana if process is executing, any process is executing in its critical section, there's no other process can be executing in their critical section. Kalau dia tengok ada proses yang tengah run dia punya critical section, so proses lain yang nak run juga critical section kena tunggu. Okay, alright. So the progress, okay, if no process is executing in its critical section and there exist some processes that wish to enter the critical section, then the selection of the process that will enter the critical section next cannot be postponed indefinitely. So dalam syarat yang kedua dalam critical section problem, we have a progress. So progress ni dia punya syarat dia ialah kalau tak ada proses yang execute dia punya critical section dan some process dia dah request, okay, dia nak request to enter dia punya critical section, only those process that not executed in the reminder section can participate in decide which process will enter its critical section next. And this selection cannot be postponed indefinitely. Dah tak boleh postpone dah. So progress, okay. So bila tak ada proses yang executed critical section, okay, and ada some proses-proses yang sedang yang nakkan masuk critical section ni, okay. So apa yang OS akan buat selection ialah proses mana yang dia akan membuat pemilihan proses mana yang akan masuk ke dalam critical section dah tak boleh postpone dah. So dia tak ada postpone dah. Dia tak ada postpone dah. Dia terus progress masuk Okay. Dan yang ketiga ialah bounded waiting. So bounded waiting is the bound, okay, that must exist on the number of times that the other process. Okay, bounded waiting, there exists a bound or limit, okay, or on the number of items that process are allowed to enter their critical section after a process has made a request to enter its critical section and before that request is being granted. So the bounded waiting ni must be exist, bound ataupun limit. The bound tu macam limit lah. Kita akan limit berapa banyak number of items, number of times of the process can be allowed to enter the critical section after a process has. Dia akan kira selepas proses tu dah request for the critical, dia dah masuk ke dalam request for to enter the critical section dan before the process can be granted dia punya requests. Okay, kita assume each process ni they execute non-zero speed. However, we can make no assumption concerning, okay, the relative speed of the end processes. Okay, at a given point in time, the many kernel mode process may be active in the operating system. So as a result, the code implementing an operating system kernel is subject to several possible race conditions. So akan berlaku possible race condition lah. Okay. So that's why bila kita buat two general approach to handle critical section in the operating system ialah kita akan buat dia preemptive kernel dan juga non-preemptive kernel. A preemptive kernel allow process to be preempted while it's been running in the kernel mode, and a non-preemptive kernel does not allow a process running in the kernel mode to be preempted. So a kernel mode process will run until it exits kernel mode block or voluntary use control of the CPU. Okay, so that's why kita processing kita ada preemptive and non-preemptive scheduling, dan juga dia ada preemptive and non-preemptive kernel lah. So maksudnya sama lah. Okay, so kalau non-preemptive dia maknanya dia voluntary use the control of the CPU. Kalau the preemptive kernel dia akan possibly so dia akan possibly possible the processor to release the the process terpaksa possible the CPU.